Okay, so we're talking about medians and centroids. Okay? We have this triangle here. A median is a line that comes from the vertex to the other side of the triangle, and it bisects the side, so basically makes those two sides equal. So that line that I just drew, that's the median. Okay? Well, there's three medians in a triangle because there's three vertices. So if I come from this vertex and split this in half, these two are the same. There's our other median. Okay? And then our third median would come from this vertex. It would go on this side. It makes these equal. So those are my three medians. The point in the middle where the medians intersect is the centroid. So the medians are the lines that you draw from the vertices. The centroid is the point where those medians intersect. Okay? If a problem is asking you or telling you that you have a median and it wants to know about the sides, then you can just set the sides equal because that's what a median does. But here's the other interesting thing about a median. Not only does it make the sides equal, but the parts on the inside, the vertex to the point is twice as long as the point to the side. Okay? So if this is x, this is 2x. And that's on every median. Okay? So if I do it right here, the part from the vertex is twice as long, so that's 2y if that's y. And if this is z, this is 2z. So the part from the vertex to the centroid is twice as long as from the centroid to the side. So that's a lot of things that happen when you have medians and when the medians and the all intersect at a point in the middle called the centroid. The centroid is the balancing point, basically. If we're trying to balance it on something, that would be the point that you want to balance it to make it level. Okay? So let's look at some problems. Number 1, it says that YW is the median. What is XW if XZ, the whole thing, is 17? So because that's a median, and because I'm just talking about the side of the triangle, I know that if this is, whatever this is, that's the same as whatever that is. So I can divide 17 by 2 to figure out what the part is that I'm asking about. And I get 8.5. Okay, next. So we have these medians. It tells me AX, so it tells me this part right here. And it tells me XC, which is that part right there. What do I know about those two parts? They're equal because of the medians. And it also tells me ZB. And it wants me to find AZ. So we're going to start with the two parts on the side that are equal. So we're going to start with the 3x minus 9 equal to 2x minus 4. Subtract the 2x, add the 9. Okay, I haven't used the ZB yet, but see, if I can find ZB, I know that's the answer to AZ, because I know those are equal. I found X, so I just need to plug in that X into the ZB one. I get 11, so that means AZ is also 11. Okay, let's look at some other ones. Okay, again, we've got medians here. EV is what we're looking for, and VT is 5. Okay, because it's not asking about the outside, those two things are not equal. The part from the vertex is twice as long as the part from the side. So since the side part is 5, how am I going to figure out the vertex part? Multiply by 2, because that's the longer part. So 5 times 2 is 10. All right, look at the next one. FR which is the whole side, is 20.1, and it wants me to find VR. Okay, whenever you're thinking about the whole side, I'm going to draw like a whole side here. And if this is like X, and this is twice as long as X, what's the whole side? 3X. So if I wanted to find just the part underneath, what would I do to find that? Divide by 3. It's like there's 3 parts to it. Even though this is twice as long, there's still like 3 parts to this side. So I'm going to have to take 20.1 and divide by 3 to find what I'm looking for. Okay, let's look at a couple more. Find EV, so find this part right here, if UV, the whole side, is 24. So what do you think? Divide it by 2. Because we're just looking at the side, we're not looking at the median, which is on the inside, we're just looking at the sides. And we know on the sides that they're equal. It's just the inside where they're not equal, the same. So this is 12. Okay, next. TC is 8. Find TU. Times by 2. So that would be 16. Alrighty. What is TD if TV is 29? So what would I do there? Divide by 2, so you get 14.5. Okay, let's look at 8, 9, and 10. Find the measure of WY if MW is 22. That's the part that's twice as long, so what would be WY? Divide it by 2, so you get 11. Okay. Find NW if ZW is 10. Times it by 2. Find PW, or PW is 13, sorry. What is WX? Divide by 2. Okay, try 11, 12, and 13. Alright, what is XK if GK, the whole thing, is 13.5? So what do we have to do there? Divide by 3 and you get 4.5. Good. FX is 10.6. What's the measure of XJ? What'd you do? Divide by 2. So 5.3. And then it says HX if HI. So the whole thing is 9. What do I do there? Divide by 3 to get each part, but that's not the answer because that's just this part down here, and then I need to multiply that by 2 to find what it's asking. The only other thing that they might ask you about a centroid is they might give you points and say, what is the centroid? Like it wants to know, what is that point that's in the middle, that if I draw all those medians that they would intersect, so what is that actual value? What you do to actually find it is you take all of the x's and average them, and then you take all of the y's and average them. So in this case, if I wanted to find the centroid, it would be 0 plus 4 plus 1 divided by 3. 1 plus 0 plus 3 divided by 3. And I would get 5/3 and 4/3. 5/3 is a little bit less than 2. 4/3 is a little bit more than 1, so it makes sense that that could be the centroid. So if I ever give you points and want you to find the centroid, you take the x values and average them, you take the y values and average them.